So we have around 8 problems here on permutations first, then we'll go for combinations. Okay. So this is the first question. You need not take a note of it. After finishing all the 8 problems, I'll give you time to make a note. Okay. I'm not going to go for finding the final calculation. I'll just tell you the technique. So if the answer, for example, if the answer ends with 7 factorial, I'm not going to give the answer 50/40. What's the value for 7 factorial? You know that 7 into 6 into 5 into it's 5040. I'll not give the answer 5040. You yourself find it. Okay. Right. So first question. This is on permutations. So you need not worry whether this question falls under permutation or combination. This is clearly falling under permutation. Okay. So we are dealing only permutation problems. Second set will deal only combination problems. Comprehensive problems alone, we need to find whether this is permutation or combination. But try to understand why this comes under permutation. Okay. So first question, prove that C for Calcutta is twice of A for America in respect of number of arrangements of letters. It's talking about arrangement. Arrangements with what? We are talking about permutation. So it's a permutation problem. Okay. Will not get this type of a question. Prove that will not get it. But instead, is C for Calcutta is dash. This dash you have to fill with the options. Option A, 2 times. What is twice of? 2 times of. Or option B, 3 times of. Or option D is equal to. It will be given of this format. What they're trying to prove here is, you have to prove that if C is meant for number of arrangements with respect to Calcutta, because in respect of what? Number of arrangements of letters. In case, let me go as a 2 different problem. One problem Calcutta's arrangement and another problem I'll discuss with America's arrangement. See, don't think this is a geographical problem because when we say Calcutta, we think this is a place. No. When I discuss this problem, you remember when I was discussing Yamuna, you don't think this as my name. You just think there are 6 alphabets. And what you did? You removed the repetitions. The same like here we are taking 2 words. One is Calcutta and another one is America. And we have to show what? It's twice of. So Calcutta is equal to 2 times of America. We have to show this. Okay. So let me go for Calcutta first. Yes, can you help me out? Calcutta, C for Calcutta. Can you spell it? Calcutta. Yes. First alphabet is C. How many times it appears? 2 times, right? I'll make a tick mark. Next is A. How many times it appears? Again, 2 times. Okay, let me write it here. Next is L. Appears for 1 time. You need not worry. Then C we have already taken. U. It appears for once. So you need not worry. Then T. It appears for twice. Now we have to write what is C. The C. The C is number of arrangements. In how many different ways you can arrange it. So the C is nothing but totally how many alphabets are here? You know the formula when there are repetitions, we have to write it as n factorial divided by p factorial, q factorial and r factorial multiplied. Okay, so how many are here? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is 8 factorial divided by c is repeated twice, p factorial. So 2 factorial. A is repeated twice, q factorial. So 2 factorial and t is repeated twice, so 2 factorial. Likewise, we have to do it for America also. So let me try for America. Yes, please join with me. Let me write the alphabets. R-I-C-A. A appears 2 times. So A appears 2 times. N appears once. E appears once. R also once. I also once. And C also once. So the problem is quite simple. How many alphabets we have? 1, 2, 3, 4, 5, 6, 7, I think, right? So this is meant for A because they have mentioned in the question A for America. So this is meant for A. A is the number of arrangements America could be arranged. So A is equal to, yes, 7 factorial divided by 2 factorial. Okay, actually we have to write this way. So this one has to be written as C is equal to 8 factorial divided by 2 factorial, 2 factorial, 2 factorial. This is for C, A and T. Along with L and U, you have to write 1 factorial and 1 factorial. But obviously 1 factorial is 1 itself. So you are not going to repeat it, okay. So you need not to worry about this one. Likewise, we have to do it for M. It is repeated once. So I have to write 1 factorial. For E, 1 factorial. Again, 1 factorial is 1. So I need not repeat it, okay. Yes. Now what I have to prove? I have to prove that C is equal to 2 times of A. Let me check. What is C? This is C. So 8 factorial divided by 2 factorial, 2 factorial, 2 factorial is equal to 2 times of. Twice of means 2 times of. So 2 into A. What is A? 7 factorial divided by 2 factorial. Okay. So what's the value you're getting? How can I write this 8 factorial? Can I write this as 8 into 7 factorial? What is this 2 factorial, 2 factorial, 2 factorial is 8? 2 factorial is 2. So 2 factorial into 2 factorial into 2 factorial. So it's 8. I can cancel these two. So this is happening in the left hand side. What is happening in the right hand side? 2 into 7 factorial. Let me have a 7th factorial also because I already have 7 factorial here. So it will be easy for me to compare. And divide by 2 factorial is 2 itself. I can cancel. So I get the equal to sign. Yes, it's proved. Is it clear? Obviously, we will not get this type of a question. Instead, this twice will be absent. There will be a dash. This is how many times of A? This is how many times of A? The answer will be given as option A, B, C, D. Already have worked out this problem. You need not try again in the exam hall. You can directly give the answers. Okay, so first question. Shall I go for the second question? You need not make a note of it. After that, I'll give time so that you can go for a small self-working. Going for second problem. 4 travelers are here. Okay, how many? 4 travelers are here. They arrive in a town where there are 6 hotels. In how many ways can they take their quarters, which means they can board? They can go for staying, boarding. Each at a different hotel. Yes, right. Permutation means we should not have repetition. We should not have anything common like that. So we should be all different. So they are taking quarters. Quarters means they take the hotel, they book the hotel in a different case. So if we are the 4 travelers, I name them as X, Y, Z and A. And I have 6 hotels in that town. So how many hotels? Hotel 1, Hotel 2, Hotel 3, Hotel 4, Hotel 5 and Hotel 6. Okay. Now, let me go for the first person X. He comes to the town. In case he takes this H3 hotel. Okay. Then what about Y? If he comes, he will not take H3 hotel. Instead, what he will do? He'll take H2 hotel or H5 hotel. He'll take in a different hotel. That's what they mean. See, this word is important. Actually, this may not be the practical case. If X stays in H3, I also can stay in H3. You also can stay in H3 because there are so many number of rooms, right? Okay. So how many hotels are here and how many travelers are here? 4 travelers and 6 hotels. You should be very keen about what is N and what is R. Because the question starts with 4 travelers, you cannot say N is equal to 4. We know the relationship between N and R. N should be greater than or equal to R. So what's the value of N here? 6 and R is equal to 4. We don't have any permutations or combinations saying like 4p6 or combination saying like 4c6. There's nothing exists in this format. Always N will be greater than or equal to 4. So what's the answer for this one, Pa? It's a direct problem, 6p4. So this is the answer, but obviously I request you to apply the formula and go for the final answer. Okay, you do that in the workings later. Shall I go for the third problem? Okay, third problem. It's a beautiful problem, mango problem. This happens in everybody's house, right? In how many ways can 8 mangoes of different sizes be distributed amongst 8 boys of different ages? I want to highlight the 2 words here. Same words, different. This different is meant for the shapes or size of the mangoes. Okay. And this different is meant for the 8 different boys of different ages. Okay. So if you have any 3 or 4 siblings at your home, or during the summer holidays, all your cousins come together, and if you buy chocolates, the biggest chocolate will go to the smallest one. Obviously, he's not going to eat it. He or she is not going to eat it. He's obviously going to waste it. But what we'll do? We'll give the biggest one to the youngest kid. So this is what happening in the mangoes also. But the condition is given. I want to bracket this one because this is a restricted case. Alright, here is a restricted case. What's the restriction here is? The largest one is always given to the youngest one. Remember this restricted permutation must occur and must not occur. Okay. I have different mangoes. I'm poor in drawing and also I cannot draw mangoes. Instead, what I'm going to do here is I'll just make some mangoes named as M1, M2, M3, M4, M5, M6, M7, M8. How many boys are here? B1, B2, B3, B4, B5, B6, B7, B8. You need not do all these things in your exam hall, okay? I'm just trying to explain it to you. For convenience sake, let me name this M8, the mango, the big size, because what it says, different sizes. So this is the big mango. This is the biggest mango among the all 8. And let me name this boy B4 as the youngest boy, because there are boys with different ages. So let me name this as youngest in all the 8. Youngest boy. Okay. What the question says here is, so that the largest one is always given to the youngest boy. So this mango M8 will be definitely given to whom? B4. Okay. So leaving M8, now I have to make the distributions for 7 mangoes to the remaining 7 boys. Am I right? So how many mangoes here? 7 mangoes. To how many I have to distribute? 7 boys. Obviously, this can be done in 7 factorial ways. Always remember, whenever we have this restricted case, we have to focus on the internal arrangement. Okay. Obviously, internal arrangement is not playing a big role because only 1 mango to 1 boy. So n is equal to 1 and r is equal to 1. You remember the restricted permutation formula? Can you please refer it? No issues. Can you please refer it? This is not exam at all. You can definitely refer and tell me. Yes, what's the formula? Restricted permutation formula. N minus P, P, R minus P, yeah, yeah, into R, P, P. This is the restricted case where internal arrangement is required. Yes, what is P here? What is N here? 7. No, not this. Okay, N is equal to 8. Totally N is equal to 8. What is R here? 8. Because I have to give all the mangoes to all the boys. Okay, what is P here? 1. The largest mango to the youngest one. So 1. Yeah. Now we'll apply the formula. We'll see what is happening here. Yes, apply the formula. Yes, N minus P. That is 8 minus 1 P, R minus P, which is 8 minus 1 into, remember this is about internal arrangement, which is internally distributing, which is here. What is R? What is R here? 8. What is P? Oh, sorry, this P. 1. Yeah, tell me. 7. P. 7 into 8P. 1. Okay. See, you'll get the 7P7 is nothing but 7 factorial itself. What is this 8P1? Actually, you have to get 8. But what happens here is, this one mango will be distributed to one person. So you cannot write this as 8P1. Instead, you'll write this as 1P1. Why this is 1P1 means you have to take this as a different problem, because once you get the basket containing 8 mangoes, what you'll do is you'll keep this one largest mango and keep it aside. You'll break us 2 different problems. So you'll get this as 1P. Okay. So what's the problem here? 1P1. You may again ask me why this formula is not working out here. Because there is one person, there's nothing to arrange. Remember? Is it right? Because there is only one person, you are not going to arrange anything here. If there are 2 persons, obviously this problem will definitely apply with this formula. Okay. So it is not 8P1 here, it is 1P1 here. So I'll place a star mark. Okay. So sometimes what happens is, if you apply the formula directly, you will not get the answer. You have to apply the logic. I'll go for the 4th problem. Shall I continue? I'll go for the 4th problem. In how many different odd numbers, I want to highlight this word, odd numbers of 4 digits can be formed with the digits 1, 2, 3, 4, 5, 6 and 7. The digits in any number being all different. So this is a basic problem. All different odd numbers can be taken and there should not be any repetition. What permutation says is you should not have any repetitions. Okay. How many numbers are given in total? 1, 2, 3, 4, 5, 6 and 7. So totally I have n is equal to 7. I have to take R. What is R? I have to form 4 digits only. So R is not 7 here. What I have to do here? I have to form only a 4-digit number. 4-digit number, you know this place. This is called as ones place. This is called as tens place, 100 place and 1000 place. When you call a number as an odd number, when you have this one place ending with odd number, right? What are the different odd numbers you have here from our question? 1, 3, 5, and 7. So in how many ways you can fill this one? This final, this ones place. In how many ways you can fill it? There are 4 different ways to fill it. So you have this as 4. Okay. Now come for this one. The remaining 3 places. Make it as 2 different problem. Yeah. In how many ways you can fill this? This is also again a restricted problem only. Yeah. In how many ways you can fill this? Make it as a 2 different problem. What is n? In case if you fill this one with ones place with 7, in case for example you fill this last place with 7, so the other 3 places can be filled with 1, 2, 3, 4, 5, and 6. So what is n? 6. Okay. What is r? 6 only. Sorry, 3. Thank you, Pa. 3. So in how many ways you can do this? 6p 3 ways. Is it okay? Let me repeat it. Here n is equal to 7 because we have 1, 2, 3, 4, 5, 6, and 7. R is equal to, actually it should be 4 because we are going to fill 4 places. Because this last place is to be fixed by a odd number because we want to find different 4-digit odd numbers, I can fix this place with 1 or 3 or 5 or 7. So I have 4 different options or opportunities. And so I multiply. Okay, so I multiply. And the remaining 3 places. Now R is not 4, right? R is now 3. The remaining 3 places can be filled with the remaining 6 numbers. Because, for example, if I take 3 or 5 or 7 here, the remaining numbers cannot be repeated. Okay, so n is equal to 6 and r is equal to 3. So this can be done in how many ways? 6p 3 ways. This can be done in 4 different ways. So the final answer here is 6p3 into 4. If you apply the restricted formulae, actually this will be 4p1, which is nothing but 4. Okay, so you can write it as 4p1 or you can directly write as what? 4 itself. Is it okay? So this is problem number 4. Can please make a note of all these 4 problems before I continue with the rest of the things, please? A small discussion on problem number 3 and problem number 4 before we continue with the rest of the problems. See, both falls under restricted case. No doubt in this, right? Why this falls under restricted case? Because in first problem, we have that the largest one of the mango should be given to the youngest boy. This is one restriction. And in the fourth problem, we have that we are not going to form just a 4-digit number. Instead, we are going to form odd numbers. Okay. When it comes to restricted permutation, our formula is n minus p, p, r minus p, r, pp. Okay. Now the problem here is, in this problem, when we apply this formula directly, we will not get the answer, but here we get it. Why this is the issue means, here, largest one, youngest boy, both are conditions. Okay. What happens in both cases, we have so many numbers, but what happens? Only 4 odd numbers are present. What are the odd numbers present? What are the odd numbers present? 1, 3, 5, and 7. From these 4 odd numbers, I have to fix only one place. Which place? Ones place. See, this is the ones place, right? We call this as the ones place. From the available 4 odd numbers, I can fix any one number. That's why this seems to be applicable like 4p1. So, directly don't relate this R and this R. This may not be working always. So that's why we cannot always go by the formula side. We have to sometimes what? Relate logically and let the formula apply. Okay. But what happens in this case? The third problem, what we did, you remember? It's 7p7, which is 7 factorial, into, we did not do 8p1. What we did? Only one largest mango, only one youngest boy. Okay. So that one mango will be given to that one boy. So it's obviously this is 1p1, which is 1. So you may get your answer as, this question was asked once in the exam, you may get your answer as 7 factorial into 1 factorial. So you cannot always expect, see, what are the different options you may have is, one case it may be like 50-40 because obviously 7 factorial is 50-40. So this may be the answer. Or you may have the answer as 7p7 directly. Or you can have it as 7 factorial directly. Or you can have it as 7 factorial into 1 factorial. That's obviously right only. can have as different ways. Don't think that you remember in your school days, after finishing the full problem, you have to write as answer is equal to, give the answer and box it. You remember all these? If you don't write this one, you'll not get 1 mark. Okay. The same thing happened in my school days also. You'll not get this 1 mark. So you have to write the answer separately and box it. Okay. You're not going to do all these things. Each and every stage matters here. This is one step into 1p1. This is one step. Okay. The next step will be 77 can be written as 7 factorial into 1 factorial. This is another one step. And the last final answer 50-40. This any one step can be answered in the options. So from that A, B, C, and D, you can have any one step as the answer. Okay. So this is about the fourth and third problem. Let me go for the first problem. Okay. So problem number 5. Yeah, this is a beautiful problem. There is a certain particular logic. Let me take you through the problem first. In how many ways can the colors of a rainbow, you know the colors of the rainbow? Vibgyor. Okay, so this need not be mentioned in your question. We know it's Vibgyor. Be arranged so that red and blue color, option A, which is subdivision A, always together, subdivision B, always separate. You have seen the original rainbow? You have seen the original rainbow? What colors will be there? First you'll have, so it will be like this, right? First you'll have violet, then indigo, then blue, or whatever it is, okay? So you know this is the pattern of the rainbow. We are not learning geography, we are learning math, obviously. So now our problem is red and blue are always together. This is one question. And second question is always separated. Yeah, tell me. Before working out all these options, let me go for basic problem in how many ways you can arrange it. Total number of different ways of arrangement. Total number of arrangements you can make. If there are no subdivisions given, yes, tell me how many colors in total. How many number of arrangements you have to do with respect to all the colors. So R is equal to 7. So the problem here is very simple. 7p7, which is 7 factorial ways. Now problem with respect to subdivision A and B is always together one case and always separated another case. See, it can be red and blue, or it can be violet and red, or it can be orange and red. Any number of combination, you don't worry about that. Okay. Just to give meaning to that, two colors are given. One is red and blue. Okay. If you go for this one combination, so how many different combinations you'll get? Totally 50-40 combinations. Did you try working your names? Okay. Who has the lengthiest name here? Above 6 letters. Anybody names above 6 letters? Yeah. Can you spell your name? S-A-N. No? What's your name actually? Oh. Okay. Sanjana Priyadarshini. Check, I'm writing the right spelling. Priyadarshini. Okay. So how many days you took to find number of ways? How many letters are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. I think I asked the wrong person. I should not have asked Sanjana Priyadarshini. Okay, I think 21. So n is equal to 21. Actually, R is equal to 21, but we get repetition with respect to A itself. 1, 2, 3, 4, 5. So 5 A's. So you did all these working, right? For example, if I take Sanjana alone, here itself is so many A's. If I try working the number of permutation with respect to Sanjana alone, so I'm dropping Priyadarshini. Only Sanjana is here because it's a very big name. So what happens, Sanjana here is Sanjana. I should write it as Janasan. Yes. Okay. Shall I write it as Njasana? Yes. Different ways I can write it. This is what happens with this case also. When I talk about the color of the rainbows, Vibgyor, I can arrange in how many different ways? 50-40 ways. But in the sky, you get only one option. What option? Vibgyor. But if I try arranging, I'll get so many options. Okay. For example, one option may be violet, indigo, red, blue, yellow, orange, green. This may be one option. For example, another option may be violet, yellow, orange, green, blue, indigo, red. If you have a keen check, what I have done here is, in the first case, I have taken red and blue together. The second case, I have taken red and blue separated. This is the first example. See, always together. Whatever different combinations you try, you make different arrangements with respect to V, I, yellow, orange, and green. This red and B will always be together. So you know the school friends, these two friends always be together. Okay. And obviously, when you go for the second case, what happens? Red and blue always separated. See, any number of ways you can arrange this one. What happens with red and blue? They will not be together. Okay. Again, you can find two classmates in your class there. They will not be together always. Okay. So in this way, in how many ways you can arrange always together case and always separated case? Actually, we'll work out for always together case. Instead of seeing blue and red as two different colors, I'm going to combine and make as one color, which means actually because this is about color problem, I'm making as two as one color. If there are two different persons, instead of giving two different places, I give one place. Okay, so for B, I'll give separate place. For I give a separate place. Okay, for blue, if I talk about blue, automatically who comes? Automatically which color comes? Red color comes. So this together I make it as one place. Okay, okay. Then what's the next color? Green. I'll take it as separate place. Yellow. I say take it as separate place, and orange. So instead of taking n is equal to 7 and r is equal to 7 here, I'll not take r is equal to 7 and n is equal to 7. How many different colors are here now? Different color means different cases because I have to combine this as together. So 1, 2, 3, 4, 5, 6. So n is equal to 6 and r is equal to 6. So obviously, in how many ways I can arrange it? 6p, 6 ways, 6 factorial ways. Okay. Now, please make a note here. When we talk about blue and red, also, we have to talk about red and red because we are talking about arrangement. Blue and red is different and red and blue is different. So obviously, I have to say that n is equal to 2 and r is equal to 2, which can be internally arranged as 2 factorial way. You agree with? See, this is one arrangement I have taken, right? What is the arrangement? B, I, R, B, Y, O, G. In case, for me, let me go for the third one. B, I, P, R, Y, O, G. See, first and third are right, different, right? First case, I have red first, then blue. What happens in the third case? I have blue first, then red. Both are different. So even though I give one place for, there is one question for blue and red, it can be blue red or red blue, which has to be internally arranged. So this is taken as n is equal to 2 and r is equal to 2, which is nothing but 2 factorial. So in how many ways the red and blue together is 6 factorial into 2 factorial. Okay. Let me finish off second option also. B, the question second subdivision B, always separated. See, when I talk about total number of arrangements, I will find that red and blue together, red and blue separated. So together case I will get. Also, I'll get separated case. I'll have total number of arrangements. So in how many ways you can arrange in total? 7 factorial. Okay. In how many ways you can arrange together? See, this is the answer. 6 factorial into 2 factorial. So obviously in how many ways you can separate it? 7 factorial minus 6 factorial into 2 factorial. So this is the answer. Okay. Obviously, here alone you can find the separate answer. What is 6 factorial? 720 into 2. You can, I think it's 1440. We can give 1440 as a separate answer. If this is asked separately, can give the separate answer. If, however, the separate case can give this as the answer. Or you can give 5040 minus 1440 as the answer. So this can be taken as one answer also. This can be taken as a. Is what happens in this problem. Show that the number of ways in which 16 different books can be arranged on a shelf so that two particular books shall not be together. Okay, shall not be together. So just imagine you're in a library. So you have visited libraries, right? Or you keep all your books in an arrangement at your home in a shelf. You have like 4 accounts book. What you do? You keep it separately in different shelves. or in one single rack, you keep it in order. Okay, so you have like a 4 accounts book, 5 math books, okay, 1 economics, and so on, like this. And how many books are given in the question? 16 different books. It is not the same books, it's all different books. So that two particular books shall not be together. It's the same Vijaya problem. In how many ways totally you can arrange it? 16 ways. Okay, which means 16 factorial. 16 different books in 16 ways, so 16 factorial ways. If the particular books are always together means what happens? You should not take this as 16 different positions. You should take this as 15 positions. Why this is 15? Because these two books are now clubbed as one single position. Okay. So now you have n is equal to 15 and r is equal to 15. So which can be done in 15 factorial ways. But what about this particular book? Book 1, book 2 or book 2, book 1. You go for left to right arrangement, right to left arrangement. So if you go for left to right arrangement, book 1, book 2 will be there. If you go for right to left arrangement, book 2 and book 1 will be there. So the order is different, right? So that can be done in 2 factorial ways. Now the question is about not together, which is separated. So this is 16 factorial minus 15 factorial into 2 factorial. Is it okay? But now the question asked here is to show that it is 14 into 15 factorial. Just a small simplification is enough. So what you do here, instead of taking 16 factorial, I'm going to take, say I want 15 factorial in the answer. So instead of taking 16 factorial, I take this as 16 into 15 factorial. Put it in brackets. 15 factorial into 2 factorial. Here 15 factorial is common. I can take it out. So 15 factorial taken common. What is left out here? 16. And what is left out here? 2 factorial is 2. So minus 2. So this is 15 factorial into 14. So I can write this as 14 into 15 factorial. Is it okay? Hope it is okay. Shall I take out to the next problem? Yeah. So next problem here. So this is a direct problem. Question number 6. Circular permutation. In how many ways 5 boys form a ring? You remember the formula for circular permutation is not n factorial. Instead, this is n minus 1 factorial, which is 5 minus 1 factorial, which is 4 factorial. So the answer is what, 24. Yes, B. In how many ways 5 different beats? So you're not going to distinguish between clockwise and anti-clockwise. So what's the formula? N minus 1 factorial divided by 2. Why 2? Clockwise 1 arrangement, anti-clockwise 1 arrangement. So 2 arrangements. Okay. So this is 24 divided by 2, which is 12 is the answer. Shall I take over? So let me finish off 7th and 8th. Then I'll give you some time to make a note of those. Yeah, 7th one. If the letters of the word daughter are to be arranged so that vowels occupy the odd places, in how many number of ways you can get the words? Okay. Let me go for daughter. How many alphabets are here? D, A, U, G, H, T, E, R. 8. So totally n is equal to 8. Which means you'll have 4 odd numbered positions and 4 even numbered positions. You agree with me? Okay. There is no mention given about different words is only given. There is no mention given about how many letters there it should be in the words. Which means R is also 8. So you're going to form a 8-letter word. Okay, how many have taken 8-letter word? So obviously, how many odd places? So these are odd places, right? Odd, 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 odd. What they say in the question is, it's again a restricted case. What they say in the question is, vowels should occupy the odd places. Now let me segregate the vowels and consonants. So what are the vowels present and what are the consonants present? Yeah, help me out. Vowels. So let me go in order for convenience sake. P is a consonant, A is a vowel, then U is a vowel, G is a consonant, H is a consonant, T is a consonant, E is a vowel, R is a consonant. Okay, yeah. Now come here. How many vowels in total? 3. How many odd places? Because vowel should occupy odd places. How many odd places? 1, 2, 3, 4. So in this case, n is equal to 4 and r is equal to 3. You should not take the other way because n is always greater than or equal to r. N is equal to 4 and r is equal to 3, which can be arranged in 4p 3 ways. Hope it is okay. There is no mention given about where the consonants should be placed, which means in the remaining places, we can fix the consonants. See, it's not mentioned consonants should be in even place, right? They are mentioned vowel should be in odd place. No mention is given about the consonants, which means what are the places remaining? This is the even place, this is the even place, this is the even place, this is the even place. So how many even places we have? Four. Okay. But only three alphabets are being fitted in odd place because we have only three vowels. So three alphabets have been fitted in odd place. So remaining one place I have for odd places. So this five places totally can be taken for consonants. And how many consonants here? Five consonants. So this can be done in 5p, 5 ways, which is n is equal to 5 and r is equal to 5. So this can be done in 5p, 5 ways. So the answer is 5 factorial here. So what's the final answer? So let me have this as answer. What's the final answer? 4p3 into 5 factorial. Is it okay? Okay, right? Shall I go for the eighth one? Let me finish up the eighth one also. Eighth one, the total number of ways in which 6 plus signs, it's a beautiful problem, and 4 minus signs can be arranged in a line so that no two negative signs occur together. How many plus signs I have? Plus, 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 and plus. How many negative signs I have? 1, 2, 3, 4. See, it's not all different. It's all same only. Okay. Can be arranged in a line so that no two negative signs occur together. So I should not place two negative signs together. See, it's somewhat similar to Vijaya problem, somewhat similar to the book arrangement problem. No particular two books should occur together, or no red and blue occur together. So same like that. If I try to arrange in this, I have to arrange the plus signs first. So let me arrange the plus signs. I leave a gap between plus signs. Why means because no two signs, two negative signs occur together. So in this gap, I'll fill a negative sign. So let me please fill the positive sign. So 1, 2, 3, 4, 5, 6. Okay. So how many signs? Sorry, how many places I have for placing this negative sign? 1, 2. This is not minus symbol. This is the positions I'm denoting in green color. So 1, 2, 3, 4, 5, 6, 7 positions I have. Okay. How many negative signs I have? Only 4 negative signs. So this is n is equal to 7 and r is equal to 4 problem. In how many ways I can do it? 7p, 4 ways. Now the problem is all negative signs are same negative sign. Because we have a repetition here, I divide by 4 factorial. Okay. Before that, we arranged the positive sign, right? How many positions we took for positive sign? 6 positions. So this I worked out for negative. For positive, actually there are 6 positions. So n is equal to 6 and r is equal to 6. So this looks like 6 factorial, but all are same plus signs. You will not differentiate the plus sign. So you have to divide by 6 factorial. So the answer is 1 here. So this is 7p4 divided by 4 factorial. This is 6 factorial divided by 6 factorial, which is 1. But the option that was given in the exam was 6 factorial divided by 6 factorial into 7p4 divided by 4 factorial. This was asked in the exam. Because conceptually this is the answer, right? But if you go for the final answer, directly you will say that 7p4 divided by 4 factorial. So please make a note of this one and also this one. Yes, sir, please. So permutation problem. Small concepts can give the heading as standard results, where you can find it in all the materials. First one is about permutation part. The problem here is, let me go for the example. Okay. Uh, the example what we discussed, already we have discussed, what we discussed here is my name. Okay, you remember what we did here? Totally, it can be arranged in n factorial base. If you have any repetitions, you have to remove it. So p factorial, q factorial, and r factorial. Or you can write this one as in some material, or in the exam, you may be expecting this as n1 factorial, n2 factorial, n3 factorial, so on. The concept is same, the logic is same. What is the heading for this is where you're doing this to remove repetitions. Okay. Why you do this? To remove repetitions. Or you will find the heading as, you'll get a statement like, where n1 number of things are alike. N1 number of things are alike. Alike means same. We have seen this all small, small, cutie, cutie balls in a mesh bag. the net back. There you'll get five red color balls, five blue color balls, all five red color balls only. You cannot call this as same here because same means it's one ball can say it's same. It's not one ball, it's five balls, but of same color, same size. So you call it as alike. So alike means what? As of understanding, it's like same. Okay. N2 number of things are alike. N3 number of things are alike. Which means what? It's repeated N1 number of times, N2 number of times, and N3 number of times. In my name, A is repeated two times. So with respect to A, N1 is 2. So in case if I add M in my name, what happens here? This is N1, 2. If I add one more M in my name, it becomes N2 is equal to 2. If I add double Y, which means now it's 3 Ys. Now what is it? N3. Is it okay? So this is with respect to permutation, first one. Second one, second one. Again, this is also with respect to permutation. We were discussing one example with respect to receiving OTPs, or you fix a number for your lock, number lock. You remember this example? So in case it's a 4-digit OTP number, we'll have four places. Do not call this as place, four different numbers. Okay, it can be the same or it can be different. Yes, what's the answer you got here? You remember? What this number can be? It can be between 0 to 9. What this can be? Again 0 to 9. This can be again the same. So this can be arranged in how many ways? 10 ways. Okay, see now. This can be arranged in 10 different ways, 10 different ways, 10 different ways, 10 different ways. Am I right? And we have to do and, which means multiplication. So the answer will be here 10 power 4. Sometimes for online banking or for any online purchasing and all, you get 6-digit OTP number. Okay, in that case, what is the answer? 10 power 6. For this number lock, suitcase number lock, it will be 10 power 3 if 3 places are given. Okay. So generally, what's the formula for this is n power r. Okay, because this is an example I have taken with respect to numbers. How many numbers we have? 0 to 9. Sometimes they may be giving with G or. So how many in total? 7. They may be saying it may be repeated any number of times. So B will be repeated 7 times for 7 places. R will be repeated for 7 times 7 places. So it will be 7 per 7. Okay. Or they'll be giving only 3 places. They'll say it can be repeated any number of times. So this will be 7 per 3 and so on. Okay. So this is n power r. Yes, can please make a note of it. We have done with 2 headings. So this is with respect to that repetition is allowed. Repetition is allowed. Repetition is allowed. Either they will mention clearly in the question repetition is allowed, or they'll give this type of an example. They will not give the mention, but it will be mentioned, or you have to take from the example, it can be repeated. See, for OTP, it can be repeated. You might have got 6678, or you might have got 5242. You might have got these type of OTPs, which means 4 can be repeated, 6 can be repeated, 0 can be repeated. Okay, yes, please. So we have 2 results here. So we go for third case. Actually, third case, no. This is the first case in combination, but under the standard results, I'm naming this as third case. Okay. So this is falling under combination. Okay. The same, what we did in the earlier case for permutation. We are going to discuss the same one. Okay. See, like, we are going to remove repetitions and where repetition can be allowed. The same case. Okay. What I'm going to do here is, you know this Pascal's triangle? I've heard of or you've learned this Pascal's triangle? Hmm. You know this identity? We have learned this a plus b the whole square. Okay. A plus b the whole cube. What is a plus b the whole square? Plus 2ab plus b square. What is a plus b the whole cube? A cube plus 3a square b plus 3ab square plus B cube. Okay. You know what is A plus B the whole power? A plus B the whole power 4. A plus B the whole power 5. Okay, even I don't know. Don't worry. Don't take it very seriously. Even I don't know. Okay. You know this Pascal's triangle? No. What is this Pascal's triangle? This person Pascal. What he did is, he sounds like Pascal, no? Okay. What he did is, he started with one. It's a triangle. You know what is a triangle? It will come slanting like, okay. He starts with one and he follows this logic where at the ends you'll get one only. In between, you have to add these two values and write as 2. Okay. At the ends, you'll have one only. In between, you have to add the values and write it as here 1 plus 2, 3, here 3. Okay. So this ends will be 1 itself. So you know the identity. What's the identity? First one you have taken a plus b the whole square. Okay. You know this, right? A square plus 2ab plus b square. You take the coefficients alone. What's the coefficient for this one? 1. What do you mean by coefficient is how many times the term occurs. A square occurs for once. So this is 1. Okay. Here AB occurs for twice. So 2. And this B square occurs once. See, this is the value. Okay. This is the value. What happens for A plus B? The whole cube. A cube plus 3A square B plus 3A B square plus B cube. Yes, tell me the coefficients. 1, 3, 3, 1. Okay. So always when we talk about this cube or the square, we'll take the highest power first. Am I right? Okay. See here. What we had done? A square. Then check the terms here. Reduce the power of A, increase the power of B. When we say it's A square, this is actually A square B power 0. You agree with me? What is B power 0? Anything power 0 is 1. So when we say A square is A square B power 0. So what happens here? Reduce the power of A. Instead of A power 2, we'll take A power 1. What is the power of B here? 0. So instead of B power 0, take B power 1. See, you get AB. Likewise, for the next term, increase the power of A. Sorry, decrease the power of A. It's A power 1 here. Now you take A power 0. It's B power 1 here. You increase the power of B. It's B power 2. So ultimately, this becomes B square. Apply the same logic over here. Yes, please join with me. This is A power 3, B power 0. Now, reduce it. A square, B. Reduce it. A, B square. Reduce it. A power 0, B power 3. Okay. Now, what is the coefficients? Coefficients I can take it from Pascal's triangle. 1, 3, 3, 1. Yeah. So, this is 1, 3, 3, 1. See, 1, 3, 3 and 1. Now, can you try for A plus B the whole power 4? From the Pascal's triangle? Don't take risk and all. You go directly for Pascal's triangle. At the ends, 1. Okay. Add 4. Add 6. 4. Okay. There is another one beauty. The ends will be same. See 1, 4, 4, 6. Okay. Now let me apply over here. Yeah. What is A plus B power 4? A power 4. Shall I write directly? Yeah. Coefficient was 1. Then coefficient is 4. Remember? Coefficient is 4. Okay. Yeah. 4. A cube B. Then coefficient is 6. Please try to recall. 6. A square B square plus. Hmm. A plus B power 5. You can imagine and tell. Okay. What happens A plus B power 10? Wait, man. Let me finish off the Pascal's triangle. You need not do that. There's another one beauty in this. What is that? Is you can take the help of combinations. Okay. Actually, what is happening is we have 4. In that, you need not take any, which means R is equal to 0. This is 4C0. This is 4C1. This is 4C2. This is 4C3. And this is 4C4. What is 4C0? R is equal to 0 means default one combination will be there. So the answer is 1. You got it? 4C1. When r is equal to 1 means the value is n itself. See, get 4. And you remember there was one result we were saying NCR is equal to NCN minus R. Able to recall? If you turn the page and recall, everything is there in the material. Last class we were discussing this concept. NCR is equal to NCN minus R. Which means if I take 11P3, this will be equal to 11P8. Okay. Or if you take 5P3, this will be equal to 5P2. Remember? So this is 4 means obviously the last but the second one will be 4. The ends will be equal. So we have here 1, here also 1, right? Here 4, here also 4, right? And the center one will be, obviously you have to calculate. So 4C2 will be 6, you can check. So what is 4C2? 4 into 3 divided by 2 factorial. So you get 6. So if anybody asks you, do you know what is a plus b to the whole part 10? Yes, we can strongly say yes. Okay, so what will be the first coefficient? 10C0, a part 10. What will be the next coefficient? 10C1, a power 9, b. What is the next one? 10C2, a power 8, b square. Yes, so on. Anyway, nobody is going to ask because they need to have them to ask this question. Okay. So anybody has asked you, you know 6 tables? Not now. When you are in your fourth standard, fifth standard, you know 6 tables, you know 7 tables, you know 8 tables. 9 tables is somewhat easy. 10 tables very easy. 1 table, 2 tables, 5 table easy. They'll ask you 4 tables. There'll be a exam in the classroom or oral exam. Tell what is 4 into 6. Okay, we'll be doing it. Okay. So anybody has asked this 1 lakh table? 1 lakh into 5. What is 1 lakh into 5? 5 lakh. Okay, the same way. If anybody asks you a plus b the whole part 10, you can strongly say yes, you know. But only thing, it will take time for you to work out all these values. So why I'm doing all this is, see this value. For example, if I take for a plus b the whole part 4. What was the coefficient? 1, 4, 6, 4 and 1. This is nothing but NC0, NC1, NC2, NC3 and the last is NCN. So NC4, N. Okay. See now what happens here is if I have 5 alphabets or 6 alphabets, SINGAR, all different. Okay. I need to pick one. What happens? I can pick any one. There is no problem. So here, so not here, this one. If I need to pick two, NC2, what happens? I can take IN or I can take GR or I can take RS, any combination. In how many ways I can take it? See, I'm not talking about combination, I'm talking about combination. You should be clear in this. In how many ways you can choose this one? 6 ways. Now what happens is I'm going to choose only S. Okay. There are two cases. Either you choose or you don't choose. Do not choose. Okay. Usually we get this problem. This D comes with this stroke or that stroke. This is D or this is D. Okay. Yeah. Tell me. In the sixth combination, whether I'm going to choose S or do not choose this. Either I choose S or I do not choose this. I do not choose yes. There is one option for me. I choose yes. There is one option for me. So how many options I have for yes? Two options. That is 1 plus 1. This is for 2 for which alphabet? Yes. Likewise, I have for I 2 options. I have for N 2 options. I have for G. I have for A and I have for R. So how many different combinations I can take here? 2 power 6. This is somewhat similar to that we were working for N power R for permutation. N power R for permutation, for combination it is 2 power N. Okay. We have done this already in set theory, remember? When I was discussing set theory with respect to number of subsets, we had the same formula. This is the direct formula we are trying to derive here. This 2 power N is the number of subsets over there. In permutation and combination, we say in number of ways you can choose it. See, what do you mean by subsets? If I give you, if I give you A, B, and C, and I ask you to take a subset with singleton set, you can take A, or you can take B, or you can take C, which means you take A or you do not take E. You take B or you do not take B. You take C or you don't. So in all the different ways we can write, how many ways you can take the subsets? 2 power n. This is coming from the combination only. So 2 power n is a direct application of the combination formula over here. The same thing we'll be doing in probability also, don't worry. Okay, everything is the same only. So, so first one, combination. Yeah, tell me, what was the heading? Where repetition is allowed. Okay, in how many ways you can do it? 2 power n ways. Actually, how you got this 2 power n? Because choose one or do not choose. When you try to link this with Pascal's triangle, we were working like this for 1, 4, 6, and so on. This is nothing but 2 parent. So I'll take the next page. So I was working with this one, right? This is nothing but 2 parent. Am I right? This is nothing but 2 parent. How this 2 parent? Because this is 1 plus 1 power n. Okay. This is how you get 2 parent. Okay. See. This is NC0. This is NC1. This is NC2. This is NC3. This is NCN. If you add all these, what you'll get? You'll get 2 power n. This 2 power n is being split in different pieces. Again, you may ask me, why ma'am it's 2 power n? Why not 3 power n? You'll not get 3 power n because this 2 is choose or do not choose. Okay. Again, if you're not justified with my answer, because your face shows that how you get this answer, you're not justifying with my answer, you take this one. What is a plus b power 4? Yeah. A power 4 plus 3, a power 3, b plus, sorry, not 3, yeah, 4, a power 3b plus 6, a square b square plus 4, a b 3, b power 3 plus b power 4, right? Let me take this as 1, this as 1. 1 plus 1 power 4, which is 2 power 4. What is 2 power 4? 2 2s are 4, 4 2s are 8, 8 2s are 16. Substitute a is equal to 1 and b is equal to 1 here. We'll get 16. Let me check. Okay, ready? It's a very tough problem because you have to substitute a is equal to 1, b is equal to 1. Is what happens here. A power 4, 1 plus this totally becomes 1. So 4. This totally becomes 1 plus 6. This totally becomes 1 plus 4. This totally becomes 1. So plus 1. So what's the value? Okay. So at last what we are doing is we are writing this 16 in different ways so that we get confused and we think that maths is so tough. Okay, so this a plus b power 4, if we take a is equal to 1 and b is equal to 1, that's nothing but 2 power 4. So combination is nothing but 2 power n. Okay, where repetition is allowed. Okay, you need not write all these stories, directly you come here. Yes, how can I write this 2 power n now? Yeah, yes, yeah, NC0 plus NC1 plus last will be NCN. Okay, what do you mean by NC0? Don't choose at all. What do you mean by addition? I'm not asking the value, okay? I'm asking what do you mean the concept? What is NC0? R is equal to 0. Don't do anything. That's the default combination. What is plus or? What is NC0? Don't choose anything. So no choosing. What is NC1? Choose 1 or choose 2 or choose all. So shall I write this 2 power n as choose no or all? No or more than that. Okay, if you're not okay with these wordings, Shall I write this? Choose no, which means what? Don't choose anything, or choose more than that. Choose one or two. So more includes one, two, all. Shall I write this word? Actually, I'm not writing this word. In the exam, they ask this. This is a standard result. See how the question will be asked this? Choose, which means combination. No or more. You don't choose anything, which is NC0. You don't choose anything, or choose one or two, or in case, if your question is like this, choose one or more. Okay, please be careful. Choose one or more, which means you have to choose one, or you have to choose two, or means what? Addition, or you can choose. So then this will be 2 power n minus 1. You remember proper substance? The same formula we apply there. Actually, we are not taking that formula. We are applying this formula over here. It's 2 power n minus 1. This is all falling under which case? Repetition is allowed. Generally, combination means repetition not allowed. But this is a specific case where repetition is allowed. Yes, I can please make a note. Yeah, I'll go for the fourth result. This is also under combinations only. Where repetition is not allowed. Repetition is not allowed. Generally, repetition is not allowed. This is a general assumption. Repetition is not allowed. But what happens is, in the number of given things itself, I'll have repetitions where it will be given as n1 things alike, n1 number of things alike, as we did in permutation now in the earlier case. N1 number of things alike, n2 number of things alike, n3 number of things alike. For example, let me take, I have a box which contains 5 red balls. Okay, I may have 3 blue balls and 4 yellow balls, which means 5 red balls are there, have same color. But when you are asked to pick 2 balls, what happens? You should not pick 2 black, 2 blue, should not be 2 red. Okay, I should not have repetition. So in that case, what we do here is, if I talk about 3 blue or black balls, what happens? Tell me. Whether I'm going to choose the balls or do not choose the balls. This is the logic behind. Okay, you choose. See, it's the same logic what we are following for 2 power n. Choose the ball, or you choose, you do not choose the ball, or you choose 1 ball, or you choose 2 ball, or you choose 3 ball. Again, if you ask me, ma'am, you told 2 balls, ma'am, now why you are taking 3 balls? See, 2 balls I gave you as an example, but originally I may have so many different options. So what are the different options? No choosing of balls, or you can take 1 ball, or you can take 2 balls, or you can take 3 balls. Okay. So now what happens is, how many options I have? Choose 1 ball. Sorry, don't choose ball. 1 option. Plus choose 1 ball. 1 option. Choose 2 ball. 1 option. Oh, 1 option. 2 is the number of balls. The way of choosing is 1. You take 2 balls outside. Okay. You put your hand inside the basket. You take 2 balls. That's what they mean. Okay. Then choosing 3 balls. How many options? 1 option. So how many options you have? For 3 blue balls, you have 4 different options. Likewise, now you come here. For 5 red balls, how many options you will have? 6 options plus 1. See, 5 balls, no choosing one option. So 6 options. For this one, 6 options. For this one, sorry, not 6, 4 options. Sorry. So this is 4 options. For this one, 5 options. So totally how many options you have for choosing? 6 into 4 into 5. That's it. Again, this is choosing or more than that, which means no or more. In case it is 1 or more, what will be answered? Subtract 1. See what we did in the earlier case. 2 power n minus 1. The same thing. Here it is 1 or more. What do you do? Minus 1. This is the example. What happens in the formula here is, I have given n1 number of things alike, which means what? 5 red balls in my example. N2 number of things alike, which means 3 blue balls, and N3 number of alikes, which means 4 yellow balls. Now apply the formula. Yeah, tell me. What's the formula here? How we got the 6? 5 plus 1. Okay, which means N1 plus 1 into 4. N2 plus 1 into 5. N3 plus 1. Likewise, if you have 10 different color balls, 10 times you have to take it. And what happens here in this example? So this will go on. For number of balls given, you have to take it. What happens here? N1 plus 1 into N2 plus 1 into N3 plus 1 minus 1, because 1 or more. If it is no or more, no subtracting of 1 or more, you have to subtract 1. See, the logic for third and fourth standard result is same. Only thing is repetition not allowed here, where in the question itself, you will find repetitions. But in the earlier case, what we did, repetition is allowed by default. Okay. Yes, I can play. I can please make a note of it. So you can take this as an example and this as the formula. Okay. So that's all for today. So next class we'll go for the combination problems and comprehensive problems. And another one small logic is there. One small concept is there we have to discuss on. Okay. Thank you, Pa.